Hey all, welcome back to one other video from Smart Interviews. So today we are going to discuss the problems under Codechef Contest Starters 153 under Division 3. I am Sanjay Kumar. Let's get started. If you look at this problem, butterfly, in your garden there are exactly some red butterflies, you have few green as well as blue butterflies. And alongside you're also given few red, green as well as blue flowers. Determine whether it is possible for each and every butterfly to feed on exactly one flower. It was given some condition saying that one in one, no two butterflies feed on same flower exactly in the same manner, and every butterfly feed on a flower whose color is different from its own color. In the sense, red cannot feed on red flower, blue cannot feed on blue flower. In the sense, blue can feed either on green or else red flower. Yes, and alongside in the same manner for blue. Yeah. Let us go for the input. You are given 2, 5, 4, and output for this is going to be yes. In a sense, true. Let us see it red, green, and blue 2, 5, and 4. So it's going to be 2, 5, and 4. So as it was mentioned very clear, something like this red cannot feed on red itself. That means this red can feed either on green or else either on blue. Yes. So if it want to feed either on green or else blue, the count of green as well as blue flowers should be greater than the count of red flowers. Yes. The count, sorry, the count of green plus the count of blue should be greater than the count of red. Even if it is equal, nothing wrong. Even if it is equal, the number of flowers which we are having, based on the number of flowers, all the butterflies can feed on all the flowers in the count of green as well as count of blue. Yes, this is fine. In the same manner, if you want to go for green, the count of green should be always less than or equal to the count of red as well as blue. Yes, exactly same condition for all three. Yes, if all the three conditions satisfies, you're going to return true, or else you're going to return false, saying that the conditions are not satisfying because you cannot allocate all the flowers in the respective condition for all the butterflies. Yes. Instead, can I just simply say, what if the count of red, what if the count of red is greater than the green, count of green plus count of blue? Yes, at this case, if it is greater than or equal, the red is less than, you're going to return true. But what if the red is greater? Simply, can I just simply return false? Yeah. So even if this condition is true, or else, what is the other condition? What are the other two conditions? What if blue is greater than red plus green, or else what if green is greater than red plus blue? If any of the conditions satisfy, you're going to return false, saying that you cannot allocate all the flowers in such a way that based on the conditions required. Yes. Let us try to convert the same code. So what we're supposed to do? Firstly, as mentioned in the input, you're supposed to take test cases as well as red, green, and blue flowers. Yes. So for I, so I'm taking n value and iterating for n number of times. So what I'm supposed to do? I need to take red, green, and blue. Instead, I'm just taking it as A, B, and C. So A comma B comma C is going to be a list of map of int comma input dot split. Yeah, the based on the condition, it was said that what if A is greater than the count of red is greater than B plus C, or what if B is greater than A plus C, or what if C is greater than A plus B. What you're supposed to do, you're supposed to print, in the sense it is not a function to return, you're going to print no, saying that this is not a possible. Else, can I just simply return, or else print yes. Once again, going to the condition, what if A is greater than B plus C, what if B is greater than A plus C, and what if C is greater than A plus B? You're going to print false, saying that this is not a valid condition, so that all the conditions satisfies. Let us run it and see what we get. Yeah, expect yes and no, exactly same. Let us run it. Yeah, all the test cases passed. Looking at the problem, make arithmetic progression. You're given three positive integers x, y, and z. In one operation, you can choose one of the values and change it to any integer of your choice. Yes. Find the minimum number of operations required to make sequence x, y, and z an arithmetic progression. It should be an arithmetic progression starting from x, y, and z. Yes. Note x, y, z are is an arithmetic progression if and only y minus x is equal to z minus y minus x is equals to z minus y. Okay, if this condition satisfies, he says, then that is an arithmetic sequence. Let us try to follow the same and let us try to work on how to get the minimum number of changes such that the x, y, and z will be in the arithmetic sequence. Let us look at the input first. So 2, 5, and 8. 2, 5, and 8. So already 2, 5, and 8 are in arithmetic sequence because with a common difference of 3. So we are required of 0 changes to make it in arithmetic sequence. Yes. Next comes 7, 4, and 3. 7, 4, and 3 are not in arithmetic sequence. So it was mentioned like with the help of 7, 4, if you can somehow make 3 as 1, we can get in an arithmetic sequence with one operation. So it was said that 7, 4, and 1 is an arithmetic sequence with a common difference of -3. Yes. So how can we solve this? In a very simple way. As it was mentioned, the input is going to be x, y, and z. Okay, to be in the sequence, it's going to be x, y, and z. Yeah, and it also clearly mentioned like y minus x should be equals to z minus y. Okay, if we concentrate on this logic, on this expression, it was mentioned like y minus x should be equal to z minus y. So can I just simply rewrite this expression saying that 2 times of y is going to be z plus x? Yes, very simple, right? This z plus x, these two numbers should be equal to twice of this number of y. Yes, if this condition satisfies, can I just simply return 0 saying that no extra changes are required and this is already in arithmetic sequence? Yes, if this is not the case, can I just simply modify any of the numbers, either x, y, or z, saying that there is one change in the values x, y, z to make it arithmetic sequence? Yes, it's very straightforward, right? Very straightforward. Let us once again verify with the input. So 7, 4, and 3. 7, 4, and 3. So x, y, and z. So as it was mentioned, like 2 times of y, it's going to be 4 times of 2 is going to be 8. 8 should be equal to x plus z in the sense 7 plus 3. 7 plus 3. So 4 times 2 is going to be 8 and 8 is not equals to 7 plus that is 10. So obviously when it is not equal, we are supposed to modify one of these numbers so that it is going to be in arithmetic sequence. Yes, very straightforward. So in one operation, I can just simply modify this to make it an arithmetic sequence. Yes, yeah. So either by modifying y to 5, 7 plus 3 is going to be 10, y is going to be 5, 5 times 2 is going to be 10. Very simple, very straightforward. So let me just convert the same logic to code. Yeah. So you're given A, B, C, and you're supposed to perform this, right? Yeah. So for input, what I'm supposed to do? I'm supposed to take A, B, C values. A, comma, B, comma, C is going to be a list of map of input dot split. So what I'm supposed to do over here? I'm supposed to verify if it is in the proper sequence. So can I just simply say if 2 times of B, if that is equals to A plus C, I'm going to print there is no rechange or no, there is no change required to perform any change required to perform in this. I'm going to just simply print 0 because no change is required for this. So if 2 times of B, if that is equals to A plus C, I'm going to print 0. Else, in one operation, I can just simply make any sequence to arithmetic, right? Can I just simply say print 1 over here, and let us try to verify what is the output with this logic. So expected is going to be 0, 1, and we got 0, 1. Let us submit this. Yeah, as expected, all the test cases got passed. Moving to the next problem, another game. So Alice and Bob have decided to play yet another game. So Alice will give Bob a non-negative integer k and a permutation p of length n. So Bob's goal is to sort the permutation in ascending order. To achieve this, in the sense the permutation is given, you're supposed to sort this. If you assume you're Bob, yeah, you're supposed to sort it. To achieve this, Bob can perform the following operation how many times as he want. Yes. So choose two indices I and j such that p of I plus p of j should be less than or equals to k and swap pi and pj. So this is the condition. You're supposed to swap pi and pj by taking ith index and jth index, making the condition satisfying, saying that p of I plus p of j should be less than or equals to k. Alice wanted to give the game maybe more challenging for Bob, so she asked for what minimum value of k it is possible to sort the entire array, entire permutation. So how can we solve this? Let us go for the input first and let us try to verify with the sample test case. So firstly, 1, 2, 3, 4, and 5, it is entirely in the firstly sorted order. So there is no, this is not required to sort. So zero number of operations or else zero, the value of k is going to be 0 for this, with the help of which we can just simply say this is sorted. Yes. And moving to the next one, 3, 2, 4, 1 with the value of n is going to be 4, 3, 2, 4, 1, and it says 5 with the value of 5 it is possible. Yes, let us try to see how the value of 5 is possible over here, and let us see what we are supposed to do. So the value of n is 4, and the permutation given as 3, 2, 4, and 1. Yes, 3, 2, 4, 1. And I just want to mention one important thing. The swap operation can be performed as many times as we can. In the sense, there is no limit for this. There is no limit for this. But there is only one thing. Always you should ensure that if this is the permutation P, you are supposed to choose, in the sense, you're supposed to pick a value K, such that P of I plus P of J should be less than or equals to K. Only if you want to swap it. If we want to swap it, swap in the sense, swap ith index with jth index of the P array and the permutation. Yes. So if you want to swap it, you're supposed to pick a value k such that P of I plus P of j should be less than k, and this value k should be fixed for the first time, and we should perform the same operation for all the elements such that entire array will be sorted. We're supposed to swap this such that entire array will be sorted. Yes. Let us go with the value of k is going to be, let us say, 6. Let us see if it is possible to swap all the numbers and get a value, get the permutation which is sorted. Yeah. So as we took the value of and k is going to be 6, let us try to do in this way. So 3, 2, 4, 1. So obviously 1 should go in sorted position. So if 1 should want to go in sorted position, it should go to the first position. So can I just simply swap these two numbers, saying that these two numbers will be getting swapped by itself? So it's going to be 1, 2, 4, and 3. Yes, 1, 2, 4, and 3. After first operation, like, we are not required to count the number of operations, but after first operation we got 1, 2, 4, and 3. 1, 2, 4, and 3. But is it in sorted order? No, it is not still in sorted order. We're supposed to swap the number because the 4 should go in sorted position. But if we want to swap this, if we want to swap these two elements, is it possible to swap these two elements with the value of k is going to be 6? Obviously no, right? Because 4 plus 3 is going to be 7, but the value k that we fixed is going to be 6. So how can we solve that? Yes, any other way to solve this? Let us see. So instead of doing it this way, can we do something like this? Yes. So obviously 4 should go to its sorted position. In a simpler manner, can I just simply swap? Instead of swapping this, if I can simply swap these two elements, so 3 plus 2 is going to be 5, So obviously 5 is less than or equals to 6. Yes, 5 is less than 6. I can say the resultant is going to be 1, 3, 4 as well as 2. Yes, 1, 3, 4 and 2. So when we got 1, 3, 4, 2, next term, I just want to make 4 to move to its sorted position. So 4 should go to the last index. So can I just simply swap these two elements and these two elements now, because 4 plus 2 is going to be 6 and the value that we fixed is also 6. So it is equal. Either it should be less than or equals. It is satisfying. So can I just simply swap these numbers, saying that the output we are going to get over here, it's going to be 1, 3, 2 and 4. Yes, so 1, 3, 2 and 4, and later on the only thing that is left over is swapping these two elements, and 3, 2 should be swapped, and resultant is going to be 1, 2, 3 and 4. Yes, so with the value of 6, we are able to achieve this. We are able to solve, like we are able to sort the entire permutation, because it was clearly mentioned like number of swaps that you're maintaining is not all required. There is no limit of swapping, but you're supposed to find the value k such that this operation can be performed. But to be more specific, when 6 is answer for this, it was requiring us to find the minimum value of k for which this process is possible. The minimum value of k with the help of which I can perform the swap operation so that entire permutation will be sorted. Yes. So what do you guys think of this? What do you guys think of this? In general sense, in the input was 3241, 3241. Yes, 3241. And obviously, if I can simply assume something like 4 should go to its sorted position, right? 4 should go to its sorted position. If we want to make 4 to move to its sorted position, obviously what we're supposed to do? We're supposed to fix a value k, and the value k should be fixed wisely such that, because when you're trying to swap it, as the limit of swapping is not at all mentioned, the least possible value of k with the help of which we can perform this operation is something like the maximum value should be always used, because p of I plus p of j, it was mentioned like p of I plus p of j should be less than or equals to k, right? Should be less than or equals to k. Obviously one of the value will be the maximum value of the array which you're going to swap with some other value. Yes, because in the entire array you're going to take a value that is maximum and you're going to swap it with some other value. Yes, and if you want to be getting some value for this, can I just simply say this value is going to the max of this array, max of the array, but max of the array. And whatever the value of p of j, to what value you're going to place it over here so that this value is going to be minimum. Yes, this value is going to be minimum. So can I just simply say this value that you're going to take is going to the minimum value? Obviously the minimum value, if I can simply assume in this permutation, the minimum value is going to be 1 over here. Yes, for n numbers the permutations are for the 1, right? 1. So can I just simply say max of the array plus 1 should be always less than or equals to k? Yes, in the sense the value k you're supposed to take it wisely such that it is going to be max of the array plus 1, max of the array plus 1. Yes, let us try to take one other example and let us see how it is working. So let us take the example something like 1, 3, 2 and 4. 1, 3, 2, 4. And you may be saying like, so as you mentioned, max of the array is going to be 4 over here. 4 plus 1 is going to be 5. But is the value k 5 is required for this example? Is the value 5, is the value k that is 5, is it required for this example? Let us try to verify once. So 1 is in its sorted position and 4 is also in its sorted position. The only thing is, if I can simply swap these two elements, then it will be in sorted position. Yes, these two elements. It's going to be 1, 2, 3 and 4. Yes, it is going to be in sorted position. Very fine, very fine. Yes, let us also take one other example and let us also once again try to verify how it is working. Yeah, so now I just want to take one other example saying that, so 2 is present over here and 1 is present over here and 3 and 4. Is this also a permutation? Yes, this is also a permutation. For this, I just want to get a value k such that I can simply swap elements on this and I can make the entire array sorted. Yes. So how can I make this? So as you mentioned, max of array is going to be 4, 4 plus 1 is going to be 5, and the value k that I need to fix is going to be 5. Let us try to verify, is the value 5 is a right fit for this example, or else somewhat we are supposed to reduce or else increase to make it right fit. Yes, let us see. So 5, we want 5, but if you see 3 and 4 are already in sorted position, as 3 or 4 in already sorted position, the thing that is left over is we are supposed to swap these 2 elements. Yes, and for swapping these 2 elements, is it required the value k is going to be 5? Obviously no, right? So with the help of this tool, so 2 plus 1 is going to be 3. With the help of value k is going to be 3, we can just simply achieve this. So can I just simply say 1, 2, 3, 4 after swapping? It's going to be in once again sorted position. Yes, it is going to be in sorted position with the value of k is going to be just 3, not 5. Just 3, not 5. That means something we have missed in this logic. What we shall make so that this logic works exactly fine? Yes, what can we make to make this logic works exactly fine? So as I mentioned, like the minimum value, this should be the minimum value such that the value k is going to be minimum. Yes, and what could be the value that is p of I that we are supposed to fix? Yes, if you think once again wisely, if you look over here, 3 is already in sorted position. Yes, and 4 is also once again in sorted position. Are we required to take 4 and swap some other element with 4? Is it required? Can I just simply say this is an unnecessary operation? Yes, as this is an unnecessary operation, I'm not all trying to include these 2 elements, 3 and 4, any of these 2 elements in this entire operation p of I plus p of j. So can I just simply include only these 2 elements? Yes, only these 2 elements. If I can simply include only these 2 elements, in the sense, if I can simply look at this part of the array, which is not starting from the first, the one that is maximum of this part of the array is what we are required to take it as p of I, the first element. Yes, if I can simply take the p of I is going to be 3, 3 plus 1 is going to be 3, sorry, 2 plus 1 is going to be 3, so 3 is the maximum value of k, so minimum value of k, with the help of which we can arrange this entire permutation such that 1, 2, 3, 4 will be sorted with the help of swapping f1 and 2. Yes, so instead of max of array, it is something like max of array which is not in its sorted position. So kind of strongly make a statement something like the value k should be max of array such that the max is not in its sorted position. The array max, is not in its sorted position. Plus 1 is going to the value k that you're going to fix it. Yes, and what if it is sorted? You're going to simply return 0 because no value k that we are supposed to fix it. I can just simply say that is entirely sorted. Alice has given me the sorted array. Yes, let us try to convert the exact same logic to code and let us see what it actually gives us. Yeah, so as per the input, it was saying something like I need to take test cases. So for I in range of input, so what I'm supposed to do, I need to take the value n is going to be int of input. After I need to take this array as input, so can I just simply say list is going to be list of map of int comma input dot split. Yes, so once we're done taking this, if I can simply go with this example once again back, so 3 2 4 1, for the example 3 2 4 1, the actual order is going to be 1 2 3 4, 1 2 3 4, the element that is maximum and which is not in its sorted position. 3 is maximum and it is not in sorted position. Yes, next as we come to 2, already we got 3 which is maximum, we are not going to consider this. Next we got 4 which is not in sorted position, we can just simply take 4. Yes, 4 is something. Next when we go for 1 is already like 4 is already the thing that we already taken which is maximum and not going to include this one. So For this, we're going to take 4 and 4 plus 1. As we're going to take 4 and we're going to swap with 1, you're going to take 4 plus 1. In the sense, the value k that you're going to fix as 5. Yes. So what I'm supposed to do? What I am just supposed to do? I need to check whether each and every element of this list is in its sorted position. And out of all the elements which are not sorted in position, they're supposed to take maximum. So can I just simply go in this manner saying that the output that we are supposed to print out, I'm just simply mentioning it as out. Let us take it as -1 as of now, or else even it is better if it takes 0. Nothing is fine. Yeah, yes. So out is going to be 0. What I'm supposed to do? I need to check whether each and every element is in its sorted position, starting from 1 to n. So can I just simply go in this way, something like for I, or else for j in range of 1 to n plus 1, indicating that 1 to n, if LST of j minus 1, saying that -1 the index is 0th index, LST of j minus 1, if that is not equals to j, indicating that this is not in sorted position. If that is not equals to j, so what I'm supposed to do? Maybe this is our answer, but out of all this, what is the answer? Maximum, right? Maximum. So out is going to be max of out that we have already calculated and LST of j minus 1. Yes. So out is going to be max of out comma LST of j minus 1. So LST of j minus 1, if it is not equal to j, you're going to take it. Yes. And this is the way that you're going to fix the out. And finally, if the out is once again 0, you're going to print 0. Can I just simply say if the output, if that is equals to 0, so I'm going to print 0, because if everything is sorted, obviously the out value is not going to be updated. Yes. And what if it is updated? Obviously out plus 1 is going to be the value. So can I just simply print out plus 1, and that is going to be our output. Let us try to verify it, how it is working. Yeah, experiment is going to be 053 and 053, exactly same that we what we got. Let me run it. Sorry, let me submit it. Yeah, all the test cases passed. Moving to the next problem, colorful tree, easy version. So this is easy version of the problem. The difference with the hard version is highlighted in the board. Okay, nothing. We are not supposed to discuss the hard one, anyways. Yeah, you're given a tree containing n vertices and n minus 1 undirected edges. You have to color each vertex of the tree with either red, blue, or green. Okay, each vertex must receive exactly one color, and there should also be at least one vertex having each color at the end. Yes, fine. Yeah. For a vertex u, define the score u to be the sum of distances from u to the closest vertices of all other two colors. Yes. Let us say if the first vertex that I am going to take, if it is a green, I need to find the score of green. This first vertex is going to be the nearest distance, the closest vertex with a different color, that is going to be either blue or else red. Yes. So more clearly, if u is colored red, the d1 is the minimum distance from u to green vertex, exactly same, and d2 is the minimum distance from u to blue vertex, and the score of u is going to be d1 plus d2. I hope that is making clear then. The distance between two vertices u and v is equal to the number of edges on a simple path u and v. So if there is a node here and next node comes over below it, the distance is going to be 1. The distance between two vertices u and v is equal to the number of edges in that particular path. The beauty of the tree is calculated as sum of the entire score, in the sense sum of scores of all the vertices, and your task is to print the minimum possible beauty of the tree, with the help of which the entire tree can be colored. Basically, this is a graph problem, because all the trees are graphs, right? Yeah. So you're supposed to color the entire graph. You're supposed to color the entire graph such that minimum possible beauty, you're supposed to print it. Yes, minimum possible beauty. So beauty in the sense sum of all scores of each and every vertex. So score in the sense the distance from the vertex to different color, other vertex at different color, which is closest one. So obviously, if you want the minimum possible beauty, you want the minimum possible score. If you want minimum possible score, the vertex that you want, the distance of the vertex that you want should be very least as possible, as least as possible. Okay, anyhow, let us take an example. Let us try to verify. Yeah. So I just took a T over here. So as mentioned, I can just simply go with either red, blue, or else green. But as of now, I'm just trying to take a red color over here. Okay. If I can simply take a red over here, so this is going to be of red. So this, if this node is of red, and I'm also having other two options of either to take, no, like other three options, either to take red, sorry, either to take red or else green or else green or else blue. And exactly same, I'm having all these possibilities over here, over here, over here for each and every vertex. Yes, it was clearly mentioned like if I take the first vertex as red, we are not supposed to take the adjacent vertex as red. We are supposed to take only green or else blue. It was not clearly mentioned. We can take whatever color that we want for the adjacent vertices as well. But we are supposed to color in such a way that the entire graph's beauty should be as minimum as possible, in the sense the score of each and every vertex, the score of the first vertex, let us say this is a source vertex, sorry, the score of source vertex should be as minimum as possible. Yes. So if you want minimum possible score, thinking wisely, what is the color that you're going to add for the adjacent node for this particular source node? Yes, the adjacent node's color is going to be either blue or else green, right? Yes, as you took the source node as red, the adjacent node color is going to be either green or else blue. Either green or else blue. Yes. So somehow I just made this adjacent node with a green color. Yes. And what is the color that I can go for the right part? Okay, let us say I'm just simply going with once again green color over this part. So if I can simply go with green color, once again I'm having other possibilities. Let us just simply go with an example. Let us see what is beauty of this particular tree, and let us also make some modifications and let's find what is the beauty of one other tree with the help of different color. Okay, let us now just go with blue for this, and red over here, green over here, blue. Yeah. So for this, if you can simply calculate the beauty of this particular entire tree, so the distance of green is at a distance of 1. So 1 plus the distance of blue eye is required. So it's going to be 2. The distance of green is going to be 1 and the distance of blue is going to be 2. So entirely the score of this particular source node is going to be 3. In the same manner, for this green, I'm having one on like blue on the left and as well as red on the right. So for this, a distance of 1 plus 1 is going to be 2, and for this red on left and blue on right, so once again 2 for this, and for this, okay, let us discuss this a bit later. For this red node, so we are having left green and right blue, so 1 plus 1 is going to be 2 once again over here, and we are left with only leaf nodes. And if you can simply calculate the leaf nodes, for blue, red is present at a distance of 2 and green is present at a distance of 1. So entirely it is going to be 3 over here. For green, red is at 2 and once again blue is at distance of 2. So it's going to be 3 over here. For this red, once again 3 over here. We are done, not one, we are not done with this. So green is present to the adjacent and red is present over here. 3 for this as well as 3 for this. Yes, if you can somehow color in this way, if you can somehow color in this way, for this we are getting something like 3 plus 2 plus 3 plus 2 plus 3 plus 2 plus 3 plus 3 plus 3. So and exactly 1, 2, 3, 4, 5, 6. 6 3 is 18. So 1, 2, 3. So 2, 3 is 6. 18 plus 6 is going to be 24. So for this, he says like 24 is the beauty for this. But anyhow, we're supposed to reduce the beauty. Obviously beauty is something like mostly the graph is required, but we're supposed to reduce the beauty. We're supposed to reduce the beauty, so coloring should be done in such a way that the beauty will be reduced. Yes. What shall we do to reduce the beauty? Let us just take this graph and let us see what modifications we can make such that the beauty will be reduced. Yeah. So as I went green on the left for the source node, what if I can simply go, let me just remove the score first. Yeah. So as I went with green on the left of this source node, as I want, like previously, the score of this particular source node is going to be 1 plus 2, because blue is present at a distance of 1 and 2. Yes, 1 and 2. Instead, what if blue is present over here itself? Yes. Instead, what if blue is present over here? If blue is present over here, blue is present over here, then I can simply say for this node, the distance of green as well as blue are at a distance of 1 and 1. So entirely score for this is going to be 2. Because if you want to reduce beauty, score of each and every node should be reduced, because each and every score, each and every node score is actually contributing for the beauty, right? Yes. We should reduce this score. Next, going to the left, we got green, in the sense blue to the left of green and red to the right of green. In the sense, once again, score for this is going to be 2. Yes, exactly same. If you go for the last leaf node, that is of blue, there is nothing at a distance, like green is at a distance of 1 and red is at a distance of 3. So this is 3. Let us see if you can somehow optimize this value 3 over this after some time. But let us just concentrate on the parent node, not just on the leaf nodes. Yes. If you go with this red, green on left and blue on right, so it's going to be once again 2 for this, or as I can just simply say green above over here and blue below over here, which are at a distance of 1 and 1. Anything exactly same, and the distance is going to be 2. Yeah. So for this, once again 3 for this, because at a distance of 1 and at a distance of 2. So it's going to be 3, and for this it's going to be at a distance of 1 and 2. It's going to be once again 3 for this. Going with this blue on the parent node. So for blue, I'm having a red on one side. I'm having once again red on another side. I'm having blue on another side. But I need a red as well as green. Instead, if I can simply modify this with green, modify this with green. What can I say about this? What can I say about this? So obviously the left is red, or else the above is red and the right is green. The score for this is going to be 2. And this is green. If this is green, okay, let us go with this red. The right, or else the above one is blue, and the adjacent, this is blue and this is green. And green is at a distance of 2 and blue is at a distance of 1. So it's going to be 3 over here. So 1 plus 2 is going to be 3 over here. Exactly for green, blue is present which is adjacent, and as blue is present which is adjacent, which is above, I want something which is also below, so that we can just simply make reduce the score, right? Yes. If I can simply modify this with red, no score actually reduces, right? Previously, if you see previously, if it is green, the score should be obviously like 1 for blue, and I need red, and 1 and 2 for green. Sorry, 1 and 2 for red. So 1 plus 2 is the score for this. But after modifying, it's going to be red over here. As it's going to be red, so at a distance of 1 is blue and at a distance of 1 is once again red. So it's going to be 1 plus 1, it's going to be 2 for this. The score for this is going to be 2. And obviously for this leaf node, if you can simply guess, this is going to be 3 once again, because red is a leaf node and 2 is present green is present at a distance of 1, but blue is present at a distance of 2. So 2 plus 1 is going to be 3. And for this, if I try to calculate, uh, so 2 plus 2 plus 3 plus 2 plus 3 plus 3 plus 2 plus 3 plus 2 plus 3. And how many threes? So 1 2 3 4 5. So 15 15 1 2 3 4 5. So 15 threes and sorry 15 plus 10 is going to be 25. So previously we got 24. So previously we got 24 and currently we got 25. Is it 24 exactly? Let us once again try to verify. Uh, 3, 2, 3, 2, 3. Yeah, we just forgot a 3 over here. We just forgot a 3 over here and exactly plus 3 and it's going to be 27 in total. So previously we got 27 and currently we got 25. That is what I'm wondering because like leaf node obviously 3 should be present but we have somehow reduced 2 over here. Yeah, we have somehow reduced uh, few values like this is a source node from 3 we have somehow reduced it to 2, so obviously the value should be less. Yes, we got 25 and previously we got 27. So what can we generally infer from this? Yes, if you're having a node, if you're having a node somewhere else over here, maybe either red or else green or else blue, whatever the color it might be, I'm just taking its two children. Its two children. It was not mentioned like it is a binary tree, just a simple graph, but I'm just taking with the two children. Yes, two children with either green or else blue. Yes, green or else blue. If this is the case, obviously these two will be present at a little distance, right? At a little distance. You might be also thinking like, sir, what if 5 nodes are present? Let me just reduce the color size. What if there are 5 nodes present? 5 nodes indicating that this is the source node and 4 to its children. Okay, this is also a possibility because 5 nodes in total and 4 edges. Yes, 5 nodes in total and 4 edges. And here, as you can simply assume, like if I paint with green, if I paint with green over here, if I paint with the red over here, and this is obviously in blue, as this is obviously in blue, and for this source node, we are getting 2 because we're having red as well as green, but for all these leaf nodes it's going to be 3 3 3 3. But instead of this we're also having a better possibility. Yes, obviously we are having a better possibility, but it was not mentioned like this is going to be the tree or this is going to be the graph because entire tree was already built by the question itself. You're not supposed to build a graph whatever you are required with a given number of edges as well as nodes, but it will also be given from the question itself. But the only thing is, if we want to take in this way, if you want to take in this way, if I can simply assume saying that for this example, this is a leaf node. Yeah, let me take a different color over here. Yeah, this is a leaf node, this is a leaf node, and this is a leaf node, this is a leaf node, and this is a leaf node. So we are having five leaf nodes in total, and other nodes which are not leaf node. Can I just simply make a conclusion over here saying that for all leaf nodes, the score is going to be 3, and for all of the non-leaf nodes, it's going to be 2. Yes, for all leaf nodes, the score is going to be 3, and for all non-leaf nodes, the score is going to be 2. Yes. So from this question, as 2 and 1 are connected, in a sense there is a node, there is an edge between 1 and 2, there is an edge between 2 and 3 for the first S case. So how can I just simply find the number of leaf nodes? Yes, because if you look over here, there are 5 leaf nodes with a cost of 3, in the sense with a score of 3, plus so 1 2 3 4 5 5 non-leaf nodes, 5 non-leaf nodes with a cost of 2, which is actually leading to output of 25. Yes, 25. Exactly same like previous. There are actually 6 leaf nodes, uh, as well as 4 non-leaf nodes, because of which we are getting 27 over there, and here we are getting 25 over here. Yes, so very straightforward logic. If you can somehow count the number of leaf nodes, those many leaf nodes times 3 plus non-leaf node times 2 is going to be the entire beauty of this entire tree, in the sense entire this graph. Yes, so can I just simply say, if there is a node between 2 as well as 3, and if there is a node between 1 as well as 2, if I can simply say this is 1, this is 2, and this is 3. Yeah, if I can simply populate an array something like, there is an edge between 1 and 2. So at 1 we have encountered, like from 1 there is an edge, from 1 there is an edge. So one edge is present from 1, And when we go for the second index, there is an edge between 1 and 2, indicating that there is also edge between 2 and 1. So one edge is also present. If you go to the second edge, 2 to 3, there is an edge between 2 and 3, indicating 3 to 2 is also an edge. So from 2 to 3, not just one, now we got two edges. In the sense, two edges are outgoing from this and incoming, outgoing as well as incoming from this, two, and one edge from this. Yes, two from this as well as one. I have not included the right part, this right part. I just only included this left part, indicating that what all leaf nodes which are present will be getting 1 to the output, indicating that the degree, can I just simply say degree, in the sense number of incoming edges as well as number of outgoing edges. Yes, if you can somehow calculate the number of incoming as well as number of outgoing for a leaf node, obviously the degree is going to be 1 because there will be only incoming but no outgoing from it. Yes, and for all other nodes, it's going to be something else other than 1. Is that clear? Yes, if it is clear, if I can simply calculate degree of each and every node, in a sense each and every vertex, so entirely number of leaf nodes times 3 plus number of non-leaf nodes times 2 is going to be the answer for this. Let us try to convert the same logic to code and let us see how it works. Yeah, as the tree was already constructed, let us just take it as an input. So for I in range of input, so what I'm supposed to do, and take a tree, yes, indicating that we are having three vertices. N is going to be int of input. As we're having three vertices, total 3 minus 1 is going to be 2 edges in total if it is a tree. Yes, basically graph to tree, n vertices, n minus 1 edges. So what I'm supposed to do, I need to iterate for those many number of times and I need to take it as an input. Yes, so for let us say j in range of n minus 1. So what I'm supposed to do, I need to take input. So can I just simply say a comma b is going to be list of map of int comma input dot split. I'm just taking a comma b as the values as input. Then after if I can somehow populate the array that we have discussed as of now, if I can somehow populate that array, that is degree array, that means we can just simply get the degree of each and every node, right? So I'm just taking a degree array, degree is going to be 0 times of n number of vertices. For each and every vertex we're supposed to get the degree, right? Yeah, so what I'm supposed to do, it is of size n and these vertices are starting from 1 till n. So can I just simply take it as n plus 1 is going to be the size for this size of this array? Yes, n plus 1 is going to be the size, or else you can just simply take n and you can say something like degree of a minus 1 plus equals to 1, saying that degree of a plus equals to 1. As I took n plus 1 as the size, I'm just saying like degree of a plus 1 equals to 1. And later on, degree of b plus equals to 1. Exactly same. I'm just taking degree of a plus equals to 1, degree of b plus equals to 1. So once I'm done with this, entire degree array will be populated. Yes, entire degree array will be populated. If I can somehow iterate on this degree array, if the degree of the particular node, if it is 1, I'm supposed to multiply 3 to the output and add it to my output. So can I just simply say out is what we're supposed to print as is going to be 0 in the very start, and what I'm supposed to do, I need to iterate on this entire vertices array that we generated. So can I just simply say for let's say k in range of 1 to n plus 1, 1 to n plus 1, I need to iterate to the degree array if degree of k, if that is equals to 1, it actually indicates that this is a leaf node. So what I'm supposed to do, out plus equals to 3 for this, because as it's a leaf node, 3 is going to score for this particular node. Yes. Else, if this is not the condition, can I just simply say all of the nodes are going to be non-leaf nodes? So degree of, sorry, not all required to verify the condition, saying that out plus equals to 2, because at adjacent nodes, obviously you're going to take a different color with the help of which you will be getting a score as well as 2. As we're supposed to reduce the score, we're taking the adjacent nodes as different color. So out plus equals to 2, and finally you're supposed to print this as the output. Let us try to run this and let us see what we're getting as output. So as expected, 813 is the output. Let us submit this. Yeah, all the test cases got passed. Okay, that's it for this video. For more videos like this, please like, share, and subscribe to our YouTube channel. And also do follow like what all videos, what all video content you are just wanted. You just put this message in the comment. Thank you for watching.